Now that we've equipped ourselves with some basic force knowledge, how do these forces interact with each other to make objects move? Before learning how to solve force diagrams, it's imperative that we learn about Newton's 3 laws of motion. Now, while I'm almost certain you've heard about these even as early as middle or even elementary school, these catchphrase explanations of Newton's first, second, and third laws are not always applicable nor helpful. For that, let's take a look at Newton's laws of motion from an AP Physics 1 standpoint. Let's start with Newton's first law, otherwise known as the law of inertia. While the common saying associated with this law is that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an external force, this law essentially describes the difference between balanced and unbalanced forces. In other words, if the total sum of forces on an object, or what's known as the net force, is equal to 0, then the object will not accelerate. It will either stay at rest or move at a constant velocity, depending on whatever it started out doing. Newton's second law states the world-famous equation F equals ma, or force equals mass times acceleration. More specifically, however, this law describes that the net force on an object will accelerate the object at a value inversely proportional to its mass. The more massive the object, the less acceleration, and vice versa. Finally, Newton's third law also has its own catchy saying to it. For every action, there's an equal and opposite reaction. Now, with regards to forces, this law actually describes every force has a reaction force that is equal in magnitude, opposite in direction, and applied onto the object that applied the original force. So, for example, if an apple is being pulled towards the earth by the force of gravity, Newton's third law would state that the apple also pulls the earth towards it with the exact same gravitational force. To see these laws in action, let's walk through this force problem here, which asks us to find the acceleration of a block sliding down a ramp that has friction on it. Though there are countless variations of force scenarios and problems, there is a simple 4-step process that solves any type of force question given. The first step is to select a system, or group of objects you want to analyze. For our problem here, the system is logically just the block, as other objects like the ramp, the floor, the air, etc. are not related to our problem, and would only complicate the situation. However, oftentimes, you may have to include multiple objects into one system, or analyze multiple systems at one time. After you decide your system, draw and label all the forces acting on this system, using what's known as a free body diagram, condensing your objects into one single point, and using arrows to indicate force vectors. For our situation here, we have gravity pulling straight down on the object, a normal force perpendicular to the ramp's angled surface, and finally a frictional force, resisting the blocks down the ramp motion parallel to the surface, rules that can all be found in my force properties and types video. The third step is to set up your force equations based on the coordinate axes of your choice. Now, because we're going to break these forces down into components, it's important to choose a set of x and y axes that makes this breakdown easy. Because the friction and normal forces are perpendicular already, let's align our x and y axes like this, so only the force of gravity has both an x and y component. From there, use the equations from our force properties and types video to write equations along both axes. For the y-axis, because the block does not sink into the ramp or fly off of it, the forces along this axis must sum to 0, remembering Newton's first and second laws. In addition, along the x-axis, the sum of these force vectors must add up to the net force on this object, which is equal to its mass times acceleration through Newton's second law once again. Solving these equations is just like your algebra class from before. Arriving at the solution, we can see that the object must slide down the ramp, accelerating along it at this value. While forces are extremely complicated at first, the process to solve problems with balanced or unbalanced forces is extremely structured and repeatable. So with that, you can feel good that you've just finished learning about Newton's laws of motion and their applications to force problems.